All right, so we're going to do the first problem on the review, just again, the background information to get to it. In order to be successful for this unit, you are going to have to make sure that in your comp book, you have your periodic table, that you have, if you need help and don't know the charges of the transitional metals and the polyatomics, that was unit 4. At that time, I'd asked you to actually go back and copy it and put it into your comp book. But if you didn't at any point, you need to do that, this weekend. And then another thing you need to make sure you have from unit 5 is the solubility chart. When we talked about double replacement reactions, which this is what we're going to be doing, this is where we get these solids to start our equilibrium reactions are from a double replacement reaction. So if you don't have the solubility chart taped into your comp book yet, you want to make sure that you do. That was back in unit 5. So it's on you to go find that if you don't have it in. A lot of you should have it because I did request you to put that in. So we're going to start here. I'll just put unit 14 review. Again, if you're in class, you have the review. I'm just going along with it. So this again is before we get to the calculation, the step before it. This is when we did the first lab. So our first reaction that you see, and the directions say all this, I'm just going to go through it though. Instead of rereading my directions, I'm just going to go through it. So the first example is sodium chloride and silver nitrate. They are both aqueous. That means they are both solutions, basically. That's the easiest way. They're both dissolved in solution. This is a double replacement reaction. So in double replacement reaction, part B says swap the partners. That's what you did in double replacement back in unit 5. So you're going to swap these two partners. And then you're going to swap them. So you're swapping, let's say, silver bumps out sodium, and you're left with silver chloride. You need to remember how to write that formula. Silver is a +1. Chlorine is a -1. So that's what it looks like. I don't know the states of matter just yet in my double replacement reaction, but I can look at my solubility chart and determine it when I figure out my next product. My next product then will be sodium nitrate. Sodium is a +1. A little clearer here. Sodium is a +1, nitrate's -1. That makes the formula. Now you need to see and look at your solubility chart. In the solubility chart, when you cross your fingers, you're either going to get an I for insoluble, which is not soluble. You're going to get an S if it's soluble. That means it dissolved and made aqueous solution. You could probably get D for decomposition. That means it decomposed. What you're really focusing on is there an I? Is there something that's an insoluble? Not soluble means that it formed a saturated solution. Saturated, by the way, is something that you learned in lab. The vocab word of saturated means you have something left over. And on the board, I showed you what that looked like. You had that solid left over. So when you go onto the chart, you need to see what those two represent. Well, when you go on that solubility chart, you find out that Ag and Cl, there's a big old I there, meaning insoluble. It formed a solid. So you can put the state of matter solid there. Excuse me. And then you go on the chart again and you look up sodium nitrate, and it formed soluble, which means that it dissolved. So it is an aqueous solution. So from this double replacement reaction, this is the one that's going to be at equilibrium. So this is your starting point. So before Wednesday, this is where we started from to make our expressions at equilibrium. Our KsP is based off this. So from this, I can then make my equilibrium, right? This is my solid form. I know that silver is a +1, so I'm going to write +1 or plus. It's now in aqueous form because it's dissolved. And then I have my Cl, and it's negative. So all this is very familiar because we've been working on this. The next step on Wednesday was, if I gave you these two concentrations, can you calculate it? Well, let's make sure I know my KsP is concentration of silver times the concentration of chlorine over 1, because solid isn't part of your expression. I want to note here that sometimes we like to say KsP, the equilibrium. Sometimes we'll say I'm sorry, not that. We'll say K equilibrium. That's another way. Sometimes I think Khan Academy, or maybe I've even written it as a K, all mean the same thing, right? All interchangeable. And I try to use all three of them so you get in the habit of seeing that they're all the same thing. So KsP, K equilibrium, you've got that expression. Now the first page of the review, that's where you stop. So that's what got us to Wednesday, when I gave you then 2 values and you plugged them in and you solved for KsP. And then Thursday came around, yesterday, and then I gave you KsP and I asked you to solve for the concentrations, right? So this first page is just basing it, how did you get to this point to solve for these 2 values, which eventually came down the road. Okay, so I want to make sure I gave that example for you, which is the first page that you'll be practicing today.